In section 1.3, we will talk about the basic trigonometric functions. And just like with section 1.2, we're going to be using these for the remainder of the semester. So of course, we're laying the foundation for the rest of the course, and this section is going to be extremely important. Now, let's say that you want to know the height of a tree, okay? But you don't have the means to climb up there and measure it. So how could you do this without climbing to the top and dropping a rope down to measure? Well, we can use trigonometry and trigonometric functions by using the shadow of the tree. So this we can measure, right? This is the shadow. We can measure this without climbing the tree because it's horizontal. And we can measure this angle here. This is called the angle of elevation, which we'll talk more about later on. And it's pretty amazing, but using just these two, we can figure out what is the height of that tree. And this is one of the ways in which trigonometry is used, and we'll talk more about this now. So the basic trigonometric functions which you need to memorize are as follows. So in any given right triangle, we know that the side that is opposite the right angle, that is called the hypotenuse. So this is your right angle here, and opposite the right angle is always going to be the hypotenuse. Opposite is, imagine you're going directly across. That is going to be your hypotenuse. Now, here's how you know. So the hypotenuse is usually easy to distinguish because it's diagonal, right? But the adjacent and the opposite are going to be extremely important. So here's how you know which side is the adjacent side and which side is the opposite side. So the adjacent side is always going to be the side that is connected to the angle. Whatever side is connected to the angle, that is going to be the adjacent side. All right, now what is the opposite side? Well, the opposite side is the one that's across from the angle. Whatever angle we're looking at, the opposite side is the side that is going to be across from the angle. Okay, across from the angle is opposite, connected to the angle is adjacent. So we have these three basic trigonometric ratios: sine, cosine, and tangent. Sine is opposite over hypotenuse. It's the ratio of, for any given angle, it's going to be the ratio of the opposite side divided by the hypotenuse. Cosine is going to be the ratio of the adjacent side of any angle, that's the side connected to it, divided by the hypotenuse. And tangent is going to be the ratio of the opposite side divided by the adjacent side. Now, to help us remember this, we're going to use something called Sohcahtoa. Okay, so remember Sohcahtoa. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. If you ever forget this on a test, just write Sohcahtoa, and you'll have all the ratios right there. So remember, the adjacent side is the side that's connected to the angle, and across from it is going to be the opposite side. And the hypotenuse is going to be the diagonal. So for angle beta, so this is alpha, beta, and gamma. For angle beta, identify the opposite, the adjacent, and the hypotenuse. So now imagine we're looking at this from the perspective of beta. Okay, the hypotenuse, I think, might be the easiest. Hypotenuse is going to be the diagonal, or the side opposite the right angle. That's going to be C. Now, for beta, the adjacent side might also be easy because look at angle beta and think about what side is connected to angle beta. Well, two sides are connected to it, C and A. But C is the hypotenuse, so that can't be the adjacent side. So the adjacent side is the one connected to it, which is going to be side A. Which means the only remaining side is going to be the opposite side, and the opposite side is the one that's across from angle beta, and that's going to be side B. Okay, so the next one says for angle B. So now we're looking at it from the perspective of this angle. Identify the opposite, the adjacent, and the hypotenuse. So I'm going to write this down as adjacent, opposite, hypotenuse. All right, so hypotenuse might be the easiest because it's directly across from the right angle. The hypotenuse is going to be 10. Now the adjacent, remember, we're looking from angle B. Adjacent is the one that's connected to angle B. So angle B is made up of two sides. It's made up this side 10, but that's the hypotenuse, and also side A. So the adjacent side is going to be side A, and then looking at the perspective from angle B, opposite of it is going to be side B. All right, so helpful hint, label each side as opposite, adjacent, hypotenuse with the relation to the given angle. That'll help you find these ratios. So we want to find out the sine, cosine, and tangent of angle B. So we're looking at this from angle B. Before doing anything else, let's first label the adjacent, the opposite, and the hypotenuse. Well, I know my hypotenuse is going to be opposite the right angle. So my hypotenuse is going to be 13. Now I'm looking at it from perspective of angle B. The side that's attached to it is 5, so my adjacent side is going to be 5, and across from it is 12, so my opposite side is going to be 12. Okay, so sine of angle B is going to be, remember Sohcahtoa, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So sine is going to be opposite, which is 12, over the hypotenuse, which is 13. Okay, so this is the opposite over hypotenuse. Cosine of B is going to be adjacent over hypotenuse, so the adjacent side is 5, over the hypotenuse, that's 13. And then tangent of B is going to be opposite over adjacent, so opposite of B is 12, and adjacent is 5, so then this is going to be opposite over adjacent. Let's do the next one in class. Okay, next question says, which trig function would you use if the above information was involved in the problem? All right, so we're given angle B, and the first thing we're going to do is label each side. So across from angle B is going to be the opposite, across from 90 is going to be the hypotenuse, and connected to angle B is going to be the adjacent. So now let's take a look at which information are we given. In relation to angle B, we're given the adjacent side, and we're given the hypotenuse. We're given the adjacent, and we're given the hypotenuse. In Sohcahtoa, the adjacent and the hypotenuse are related by the cosine function. Sorry, it's not beta, it's b. So which trig function would you use? I would use cosine. Let's try another one. Which trig function would you use? So once again, I'm given angle B. Opposite of angle B is this side. Adjacent is the one connected to it. Opposite of 90 is the hypotenuse. Now I'm given B and C. So I'm given the opposite, and I'm given the hypotenuse because that's what B and C are. Right? So in Sohcahtoa, I have to think about which trig function relates the opposite and the hypotenuse, which is going to be this one, sine. So sine of angle B is going to be the opposite divided by the hypotenuse. Okay, this next one, let's do in class. Now we also have reciprocal trigonometric ratios. Okay, so we have our sine, cosine, tangent. The reciprocal of sine is going to be cosecant. Now remember reciprocal. So let's say we have a ratio A over B, then the reciprocal of this is going to be B over A. You just flip it. If we have A, then the reciprocal of that is going to be 1 over A. So the reciprocal of sine is cosecant, which is short. The short form is CSC. Cosecant of theta is equal to 1 over sine. So since we know that sine of any angle is given by the ratio of the opposite over the hypotenuse, then we know that the cosecant is going to be the reciprocal of that, which is hypotenuse over opposite. Secant is the reciprocal of cosine. So we know that cosine is given by adjacent over hypotenuse, which means the ratio of secant is going to be hypotenuse over adjacent. And then lastly, we have cotangent, which is a reciprocal of tangent. So we know that the tangent of theta is equal to opposite over adjacent. And the reciprocal of that, the cotangent, is going to be adjacent over opposite. So if we're given this triangle, we're looking at angle theta. So opposite of that is 8, adjacent is 15, hypotenuse is 17. Sine is opposite over hypotenuse, that's 8 over 17. Cosine is adjacent over hypotenuse, that's 15 over 17. Tangent is opposite over adjacent, that's 8 over 15. Now the cosecant is a reciprocal of opposite over hypotenuse. It's hypotenuse over opposite. That's 17 over 8. The secant is a reciprocal of cosine. So we know that cosine is adjacent over hypotenuse. The secant is going to be hypotenuse over adjacent, which is going to be 17 over 15. Now tangent is going to be opposite over adjacent. So tangent is 8 over 15. That's opposite over adjacent. The reciprocal of that is going to be adjacent over opposite, or 15 over 8. Okay, so in this angle, in this triangle rather, suppose that A is 65, so A is 65, B is 72, and we want to find all these ratios. So first thing we need to find out what is C. So the Pythagorean theorem states that A squared plus B squared equals to C squared. So we have 65 squared plus 72 squared equals to C squared. Now, I will leave you guys to do this work, okay, because we've practiced this before. So if you put in the work, if you add these together, this is going to give us 9409. And if you square root both sides, we're going to get C equals to 97. Now we're looking at this from the perspective of angle A. So the one connected to it is going to be adjacent. The one opposite from it is going to be the opposite. And of course, the hypotenuse is going to be the hypotenuse. So what is sine of A? Well, sine of A is going to be opposite over hypotenuse, and that's going to be 65 over 97. Cosine of A is going to be adjacent over hypotenuse. That's going to be 72 over 97. Tangent of A is going to be opposite over adjacent. That's going to be 65 over 72. Now, secant is going to be the reciprocal of cosine. So if cosine is 72 over 97, the secant is going to be 97 over 72. Cosecant is a reciprocal of sine. So if sine is opposite over hypotenuse, the cosecant is the exact reciprocal of that, which is going to be hypotenuse over opposite, or 97 over 65. And then cotangent is going to be the reciprocal of tangent. Tangent is opposite over adjacent, so cotangent is going to be adjacent over opposite, which is 72 over 65. Okay, and then the rest we'll do in class.